Part E. The air in the balloon had a mass of 0.00320 kilograms. The temperature of the air in the balloon decreased by 215 degrees C. The change in thermal energy of the air in the balloon was 860 joules. Calculate the specific heat capacity of the air in the balloon. And I've got to use the physics equation sheet. And this question is worth 3 marks. So what I'm going to do here, I'm going to underline key information as well. I've got air in balloon had a mass, so I've got mass there. Temperature of the air in the balloon decreased by, so I've got temperature decreased by that. The change in thermal energy is that. Okay, so I'm going to remember here my every root. So first of all, I'm going to find the equation. Then I'm going to write the values and convert. So it tells me to use the physics equation sheet. So I'm going to look here and I'm going to look for these words: temperature of the air, also temperature change, change in thermal energy, specific heat capacity. So I know I've got to find an equation that has specific heat capacity mentioned in it. I'm looking on the first page. There we go, specific heat capacity, change in thermal energy, mass, specific heat capacity, temperature change. Brilliant. So I've got that equation, so I'm just going to write that out. Move this a second, I'm going to write that again. So I've got, just going to copy this off my cheat sheet. So change in thermal energy equals mass times specific heat capacity times temp change. Okay, so I'm going to write it as small as I can there. I'm then going to, so I've done my equation, I'm then going to look for my next bit is values and convert if I need to. Now it's only 3 marks this question, so it's unlikely I'm going to have to convert any values. I'm going to put my line down there. What have I got? Well, I've got the mass, that's 0.00320 kg. kg, I'm happy, I'm not going to change that. The temperature change, so temp change is equal to 215 degrees C. Okay, it tells me that. It also tells me the, what else? Changing that. It also, the change in energy. So change in energy, the thermal energy is equal to 860 joules. So they're the 3 bits I've got from that data, and I've got to try and work out specific heat capacity. Okay, now if I look at the equation, specific heat capacity has the symbol C, okay, lowercase c. So I'm going to add that data, then put the numbers back in. So I'm going to enter my values back in. I've got my values. I'm going to enter them. Not going to try and rearrange yet. So change in thermal energy was 860. The mass was 0.00320 times C times the temperature change, which was 215. Okay, I'm just going to multiply these two together. Gives me a total of, I don't know what on earth that is in my head. Do that calculator. So 0.00. I'm trying to be really careful here because this is quite a fiddly number, isn't it? So 0.00320 times 215 is equal to 0.688. So 0.688 times C is equal to 860. Now I'm going to rearrange and solve. So I'm going to the penultimate part, the R, the rearrange and solve. So I enter my values and rearrange it and solve it. So I'm going to divide both sides by that. So you get C is equal to 860 divided by 0.688. So C is equal to 860 divided by 0.688 equals 12,500, and the units it gives me already down here. so I don't need to worry about the units for this question. In terms of the marks, if you're interested in the marks for that, let me just get the mark screen up on my other screen so I can see it. Make sure I give you an accurate idea of the marks. So the marks would be 1 mark for that line there, entering the data, 1 mark for correctly then rearranging to that, and 1 mark for the answer. Okay, so even if you're not sure how to do this question, you'd still get a mark just for writing that part there. Okay, hope that helps.